We're going to be studying polygons and motions. This first lesson, polygons and angles. For all the lessons, please make sure you use brain and hand techniques where you finger track and read problems out loud, highlight, underline, draw a label list. Ask yourself what you can do, not what you should do. Taking a look at the first lesson. Please make note of the location that you are watching the video and the date and time, please. Let's do a quick review. We're not going to use a calculator here. We're not going to use a calculator. Let's ask ourselves what we have here. We have two triangles. We can see here that we have a 45, and this would have to be a 45 triangle. A 45-45 triangle. And then here, of course, would be a 30-60-90 triangle. Knowing that, let's write our tables out that we're familiar with. For 45-45-90 triangle, whatever the legs are, they're going to be equal. And the hypo equals whatever the leg is times square root of 2. That's the 45-45-90 table. For the 30-60-90, whatever the short leg is, the long leg is going to be the short leg times root 3, and the hypo is 2 times the short leg. Knowing this, we are given here one leg is 12 root 2. I want you to stop the video and do your best to find all possible side lengths without using a calculator. Welcome back. Let's see what we can do here. Well, first off, we have 12 root 2, and if we know if one leg is 12 root 2, then the other leg down here must also be 12 root 2. The pattern we have here is whatever the leg is, to get to the hypo, we times by root 2. That's from right there, that table. So we ask ourselves 12 root 2 times root 2, what do we get? And we know root 2 times root 2 is 2. So 12 times 2 is 24. Now that 24 in this triangle holds, if this is the 30, this was going to be the short leg position. That 24 is the long leg position, and our x is our hypo. So now we're going to ask ourselves, to get from the short leg to the long leg in a 30-60-90 triangle, we times by root 3. Problem is here, we don't have our short leg, so we do this. We know something times root 3 gives us 24. That's what we're thinking. Something times root 3 gives us 24. You try to fill out that blank. We know we need at least a root 3 here, because root 3 times root 3 cancels that radical and gives us 3. Now we have to ask ourselves, what times 3 is 24? And the answer is 8. So our short leg over here is going to be 8, the square root of 3. Now to go to the hypo, our table says we simply times by 2. So I'm going to take this. To get to the hypo, we times by 2. So we're going to have 8 square root of 3 times by 2. In this case, only the outies influence each other. So we're going to end up with 16 square root of 3. So our hypo is going to be 16 square root of 3. We're going to be talking about polygons and angles. Polygons and angles. Polygon is just a generic name for a shape. It's a generic name for a shape. And the polygons have prefixes that dictate how many sides it has. Some of these prefixes you're probably familiar with. For example, tri is the prefix 3, and therefore we get the polygon called a triangle, which is a 3-sided shape. Quadra, or quadri, of course, is 4, so we get a quadrilateral, which is any 4-sided shape. I'd like you to go ahead and fill out what you think might be penta, hexa, hepta, octa, nona, and deca, and fill out the name of the shape. Stop the video and check your answers when you are finished. Let's see if you are correct. You should have noticed, right, penta is 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. Deca, same prefix as decade for 10. So in here, we have here a pentagon, a hexagon, a heptagon, octagon, nonagon, and a decagon. For any shape above 10, we use the shortcut called an n-gon. For example, we just call it an n-gon. If we have a 13-side shape, there is a Latin word for that, but it gets far too long. So we use the shortcut simply 13-gon, meaning a 13-sided shape. So the word poly means many. So if we have a many-sided shape, we have a polygon. It's generic for any shape. Now the word regular means if we have a regular polygon, then we have all congruent sides and angles. When we have a regular polygon, we have all congruent sides and angles. So if you were to have a rectangle does have all congruent angles, but it does not have all congruent sides. We would say a rectangle is a non-regular polygon because not all sides and angles are equal. But a square, you have all equal angles and you have all congruent sides. We would say a square is regular. Now there's a couple other terms you need to be familiar with. You might have come across these in science, and that's something called convex and concave. Think of lenses. A convex lens would be a lens that looks like so, and a concave lens would be like this. So concave means to be pushed inward. Convex means to bulge outward. A convex shape is a shape that has all its sides bulging outward, versus a concave shape would be a shape where it has a side bulging inward. Right here, this would be considered a concave concave shape. The reason why it's important to distinguish is because all the equations we're learning today only work for convex shapes, not concave. Concave follows a completely different set of rules. So here are some examples of convex polygons. Convex polygons. I would like you to try to name these. Pause the video, name them, start the video again. Let's see here. This has 1, 2, 3, 4, 5, 6, 7 sides. So this first one would be considered a heptagon. The second one has 4 sides, so of course we just call that a quadrilateral. It looks like it might possibly be specifically a parallelogram, but we aren't told that for sure, so we'll just call it a 4-sided. This, we're told, has 10 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be considered a decagon. And a 5-sided shape would be considered a pentagon. And if we knew for a fact that all the sides were equal, we would call it a regular pentagon. A regular pentagon. We're going to talk about how to find the sum of the interior angles of any polygon. The sum of the interior angles of any polygon. Let's review very simply. We learned a long time ago that when you have a triangle, that the sum of the angles, whatever they measures are, we know in a triangle the sum will always be 180 degrees, at least a triangle on a flat surface. So triangles always sum 180 degrees. Let's see if we can't come up with a pattern for other side polygons. So this first one, we have a quadrilateral. So we have 4 sides. And it has 4 sides, but if we were to divide it from one diagonal, we'd end up with 2 triangles. So if I wanted the sum, I would simply do 2 triangles times 180 each. So the sum of the interior angles is going to be 2 times 180, and of course that gives us 360. Let's check out the other shape here. The other shape is 1, 2, 3, 4, 5. So this is a 5-sided shape, so this is a pentagon. It has 5 sides. Let's count the number of triangles. It only has 3 triangles. So if I want the sum of the interior angles of a pentagon, I'm going to go 3 times 180. And of course that's 540. So I'm going to know that pentagons must add up to 540. Let's check out this last one. We have 1, 2, 3, 4, 5, 6. So that's a hexagon. We have 6 sides. Let's count the triangles. 1, 2, 3, 4. So a hexagon consists of 4 triangles. So if I want the sum of the angles of a hexagon, I do 4 times 180. And of course that gets 720. Now there's a pattern here so that you don't have to do this by hand every single time. I want you to contemplate what that pattern is in every situation. We had a 4 number of sides. We only had 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. I want you to look at that pattern from the number of sides to the number of triangles involved. And ask yourself, what is the pattern between the number of sides and the number of triangles involved? Pause and think about that. Start the video when you have an answer. Okay, what you should have noticed, to go from the first to the second, we simply minus 2 each time. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. So to get the number, the sum of the interior angles, we simply say the number of sides, which we're going to call n, we're going to subtract 2. That gives us the number of our triangles. N minus 2 tells us how many triangles are involved, times 180, which is the interior angles of a triangle. So once again, the sum of the interior angles of any polygon, a convex polygon, sum of the interior angles will always be the number of sides minus 2 times 180. Let's try a problem and see how it works. We're told, let's finger track and read, that the sum of the interior angles of a polygon is 1080. What is the polygon called? Couple points here. When we talk about called, what we're ultimately looking for is number of sides, because we name polygons by the number of sides. So let's see what we can do here. Very, very critical. The word is an equal sign. So whenever you see the word is, you're going to translate it to an equal sign. So we have the sum of the interior angles. We already have an equation for that. Sides minus 2 times 180 is 1080. Let's write this out. We have number of sides minus 2 times 180. That's the sum of the interior angles, is 1080. We want to find the number of sides, which in this case is n. So we're going to solve for n here. We're going to do that by first, rather than distributing the 180, we're going to divide by 180. That cancels. So we have here 1080 divided by 180, and I get 6. So I have my next line, n minus 2 equals, that's 6. Now I'm going to add 2 both sides. So I find out that my number of sides that we're dealing with here is n equals 8. And what is that called? That is an octagon. An octagon. So for the sum of the interior angles, it's always going to be the number of sides minus 2, put an equal sign there, times 180. So the sum of the interior angles is sides minus 2 times 180. That gives us the sum. So if I want a single one, and if it's regular, for example, let's say I have a pentagon here. and I wanted the sum of all the angles, I would do n minus 2 times 180. But if I wanted a single angle here and I knew all the angles were the same, for that, I'm going to do the sum divided by the number of sides, which in this case is going to be n minus 2 times 180 over n. That's the sum over sides. That's for the interior angles. Now we're going to talk about something called exterior angles. Exterior angles. I'd like you to take and extend with me all the sides in this hexagon. Starting here, we're going to go clockwise. So take and extend. Take and extend. Like a pinwheel. Take and extend. Take it and extend. All the way around. Okay, now I'd like you to sweep the angles on the outside. Sweep the angles on the outside. These angles that you've swept on the outside, those are called exterior angles. They're called exterior because they're outside versus interior, which is inside. This would be the interior. These angles are called the exterior. Now those have a property too. Look at the diagram to the right. All the exterior angles in that hexagon have been labeled and numbered. So there's exterior angle 1, 2, 3, 4, 5, 6. And these exterior angles have a very interesting property. If you were to pull out each of those angles, notice they're color-coded, and swing them around, the exterior angles, regardless of the shape, the exterior angles always add up to a circle. So the sum of the exterior angles will always be 360 degrees. Whether it's a decagon, a pentagon, a heptagon, the exterior angles will always add up to 360. And to get a single angle, if it was regular, again you do sum over sides. So it's the same equation as before, except in this case, sum is going to be 360 over the number of sides, which is n. That's for the exterior angles. To help you remember this, we have a quick little jingle here. Let's write the equations out as we do this. It's going to be to the tune of 3 blind mice. So for now, we're just going to write the equation. It says the sum of the exterior angles is sides minus 2 times 180. So in the margin, write sum interior equals sides minus 2 times 180. That's what that line means. The sum of the exterior angles will always be 360. So we do sum exterior angles equals 360. In the middle it says, each angle of a regular polygon, sum over sides, ain't this fun? So if we want regular, each equals sum over sides. The last one, the sum of interior angles, sides minus 2 times 180. So as a repeat, the sum of the interior equals the number of sides minus 2 times 180. So students, I want you to try to sing this with me. Yes, you heard me right. You're going to sing. If you could hear the snaps, we're going to snap. We'll sing this once, and I really, truly want you to try this at least once on your own at home. Close the door so you don't scare anybody. Ready? Snap. The sum of interior angles, sides minus 2 times 180. The sum of exterior angles will always be 360. Each angle of a regular polygon, sum over sides, ain't this fun? The sum of interior angles, sides minus 2 times 180. Repeat that. Try it on your own. That'll help you memorize the equations. Now I'm going to show you how to use these equations. When you're working with these problems, you have 7 key words that you should always look for. The first key word is the word sum. Second key word is the word each or one. Next key word is interior, then exterior, the word regular. You have to look out for the number, the actual polygon sides. In other words, your n. And the last one is you want to watch out for is, are, was, and were, because that is an equal sign. We're going to do a couple problems together, and you are done. Let's take out number 1. It says, find the measure of 1 interior and 1 exterior angle of a regular hexagon. Regular means all congruent angles. Hexagon means our number of sides is 6. And we want 1 interior and 1 exterior. Well, the equation for both, for the interior, it is sum over sides. And for the exterior, it's also sum over sides. So what's the difference? For the interior, the sum is n minus 2 times 180 over the number of sides n. For the exterior, it's simply 360 over n. So for the interior angles, we're going to go 6 for sum. Interior equals 6 minus 2 times 180 over 6. And for the sum of the exterior angles is simply 360 over 6. Solve for each and check your work. So for the first one, we're going to go 6 minus 2, of course, which is 4, times 180. We're going to divide by 6. So our 1 interior angle of a regular hexagon is 120 degrees. And the exterior angle is going to be 360 divided by 6. Notice it's 60 degrees. I want you to show you a little trick. When we have a hexagon, There's a hexagon. What we just found was one interior angle was 120, so that's 120. And then if you were to extend that and get the exterior angle, that was 60. Look very closely. This is interior 120. The exterior was 60. Notice the one interior and exterior add up to 180. That will always be the case. Matching interior and exterior angles will always add up to 180. Let's try a couple more. It says 4 of 5 interior angles of a pentagon are 180, 140, and 150. Find the measure of the fifth angle. Well, first off, pent means 5. So we have a pentagon, 1, 2, 3, 4, 5. We have 4 angles, no particular order, 100, 80, 140, 150, and we want to find that last angle. So that's our question mark. Notice we have the word interior. So we ask ourselves, we want to find the sum of all 5 of the interior angles. The sum of the interior angles is sides minus 2 times 180. The sum of the interior angles is 5 minus 2 times 180. That's 3 times 180. And that's 540. So the sum of all 5 angles, the interior angles, must equal 540. Let's see what we have. 4 of the 5 add up to 100 plus 80, 140, and 150. Is 470 altogether. That's for 4 of the angles. So to get the fifth angle, we're going to take our total sum, 540. We're going to minus our 4 angles, 470. And we're going to get 70 degrees. So our last angle here, in this case, must be 70 degrees. One more problem. It says the measure of one exterior angle of a regular polygon is 36 degrees. What is that polygon called? Remember, when we call polygons, we call them by their sides. So when you're asked what is the polygon called, you're basically being asked how many sides does it have. So the measure of one exterior angle. So we want to write one exterior angle is an equal sign, 360, 36 degrees. How many sides does it have? So we know that to find a single exterior angle and it's regular, it is sum over sides equals 36. What is our sides and what is our sum? We know the exterior angles always add up to 360. So we have 360 over an unknown number of sides gives us 36 degrees. So we're going to solve for n here by cross multiplying. Next one reads, I have 36 times n equals 360. So to find the number of sides, I'm going to do 360 and divide by 36. That's 360 divided by 36, and of course that's just 10. So we have here our number of sides is 10, that's called a decagon. What is it called? It is called a decagon.